Till now we have seen the triangular law of vector addition. What does that mean? Suppose if I have two vectors a bar and there is another vector b bar, then the triangular law of vector addition states that if I take this second vector and puts its tail on the first vector like this, then the resultant after addition of these two vectors is going to be this vector which starts from the head of the tail of the first vector and ends at the head of the second vector, right? So given the magnitude, as I told you, if this magnitude is 3, this magnitude is 2, it is not necessary that a bar plus b bar magnitude is going to be 5, the addition of these two. Now the triangular law of vector addition has its limitations. Why? It cannot tell you the magnitude of the resultant vector given the magnitude of these two vectors, right? That is one of the limitations of triangular law of vector addition. And that then parallelogram law of vector addition comes to rescue. It tells you not only the magnitude of the resultant vector but as well as the direction of the resultant vector. So parallelogram law of vector addition is more general, okay, and it is very important to study this parallelogram law of vector addition. So let's look at that. Okay, now see this. Suppose I have two vectors. Let's say this is a vector a bar and there is another vector. Let's call this vector as b bar. Okay, yeah. Now let's say the angle between these two vectors is theta. Now this is also an angle between these two vectors. This is a 360 minus theta, but we will not take that 360 degree minus theta angle. We will rather take the smaller angle between this a bar and b bar vector. Okay, now they are sharing the tails. These two vectors are sharing the tails. Now parallelogram law of vector addition is mostly applied in these cases where you have a block and the two forces are acting like this. Now both of these vectors share the tail with each other, right? And from here then you say the resultant is something like that. We will see that how to tell the resultant, okay, its magnitude and direction. We will see that. So now this is general two vectors a bar and b bar with the angle between them to be theta. Okay, now what I am going to do is I am going to translate this a bar vector like this. Okay, this is the a bar vector, and b bar vector I will translate it like this. Okay, like this. So a bar, so this is also a bar. Note that you can translate this vector like this without changing the meaning of that vector. Now what is our aim? Our aim is to find out the resultant's magnitude. Now what is going to be the resultant vector? See, this is a bar and this is b bar. So according to triangle law of vector addition, you are going to get these as a resultant of these two vectors, right? You can see b bar plus a bar is also going to have r bar as a resultant. You see the vector addition is commutative. A bar plus b bar is r bar, b bar plus a bar is also r bar, right? Now what is the magnitude of this vector? That is the question. If this was somehow a right angle triangle, I could have said a square plus b square under root will be the value of magnitude. But the thing is, the problem is this is not right angle triangle always, right? So how will I do that? So to do that, let me name these vertices. Let me call this as P, Q, R, S. We are going to use some geometry over here. Let's drop a perpendicular from here. Let's extend this and let's call this as point S. Now I have found out a new triangle PRS with the angle S to be 90 degree. In triangle PRS, angle S is 90 degree. Now this triangle will become a right angle triangle. Okay, so PR is nothing but the magnitude of the resultant vector. This is r bar mod, so I will just write as r. Okay. Now what is going to be PS? See, PS is going to be PQ plus QS, PQ plus QS. Now PS is PQ plus QS, but PQ is A right? PQ is A, you can directly see, but I don't know what is QS. Okay, how will I find the QS? See, if this angle is theta, this angle is also going to be theta, because both of these lines are parallel to each other. These are opposite sides of parallelogram. Sorry for this one, I didn't tell you that these vectors are all forming a parallelogram. That's why it is called as parallelogram law of vector addition. I missed it, I guess. So I am telling it again. These four vectors are forming a parallelogram. That's why it is called parallelogram law of vector addition. Okay. Now this angle is theta. This is also theta. Why? Because this is, both of them are parallel to each other, opposite sides of parallelogram, and that's why this corresponding angle are going to be the same, right? Now, how will I write QS in terms of A, B, or anything, A or B, right? So now, can I say, if I say cos theta in this triangle RQS, I will write over here in triangle RQS, angle S is 90 degree, we know this. So from here, cos theta can be written as adjacent side upon hypotenuse QS upon QR. Cos theta can be written as QS upon QR is equal to, what is QS? We want to find out. But what is QR? QR I know it is going to be B. So QS is going to be B cos theta. So this is my one of the equation. Let's call this first equation. Okay. Now what is so this is A plus QS. I don't know what is QS. So from here you can see it is A plus B cos theta. Okay. Let's call this my second equation. This is for PS. Now what is SR? I can again write in terms of B and theta the value of SR. So see, if I write sin theta is SR upon hypotenuse. So sin theta is SR upon hypotenuse, which is B. So SR is equal to B sin theta. This is my third equation. So 1 and 3rd, if I put in this, okay, let's write SR. SR is B sin theta. All these things why we are doing, see, you don't have to remember all these things, okay? If you remember what is your aim, then you don't have to remember all these things, because you have to find out the magnitude in some way or the another. For that you should know RS and PS. So how will I know PS in terms of A and B? This is how I know. How I know SR in terms of A and B? Like this. It is not dependent on A. B sin theta. Okay. Now in triangle PRS, angle S is 90. So by Pythagoras theorem I can write PR square is equal to PS square plus SR square. Right? This is the Pythagoras theorem. What is PS? PS is going to be A plus B cos theta whole square. A plus B cos theta whole square plus SR square is B sin theta whole square. This is PR square. Now let's expand this and we will see A square plus 2AB cos theta plus B square cos square theta is plus B square sin square theta. Right? Okay. Now you can see, if I take common B square, then in the bracket we have sin square theta plus cos square theta. That is going to be equal to 1. So PR square, now PR can be written as R. So R square is equal to A square plus 2AB cos theta plus B square times sin square theta plus cos square theta. So sin square theta plus cos square theta is going to be 1. So that means R square is equal to A square plus 2AB cos theta plus B square. Right? Now this R can be written as square root of A square plus 2AB cos theta plus B square. Some explosion, I don't know. Okay, so this is going to be the resultant of these two vectors A bar and B bar. This is just the magnitude. I do not know about the direction. So this is the magnitude which depends on A, B as well as the angle theta. Right? Now see here, if the angle theta decreases, keeping magnitude of A and B same, you can see cos theta will increase, right? If I make it smaller and smaller and smaller, the nature of cos theta is such that if I make the angle small, cos theta will increase, right? So that means the resultant value will increase. So if somebody is pulling in this way and someone is pulling in this way, and if they make it smaller and smaller angle, then the resultant is going to be adding more, the addition of both the vectors will be more than the case where you have more angle, right? That's why if you start pulling in the same direction, both of you or both of these people, then it is going to have more effect. If the angle is more, it is going to have lesser effect, right? Okay, now look at the special case. If theta is 90, then this cos 90 will become 0, and simply you will have r is equal to square root of a square plus b square. So that verifies, right? See, if you have two vectors like this a bar and b bar, you don't no longer form a parallelogram. Oh, sorry, this is also a parallelogram, but still you can see it is a square. So this is b bar, this is a bar. This is a parallelogram, no issues. But this is a more sorry, this is not square, sorry, this is a rectangle, not square. If a and b was equal, then it would have been a square. Now this a bar and b bar going to be giving you this resultant. Now of course you can see the resultant has to be square root of a square plus b square, because this angle is 90 degree, that's the reason, and thus this angle is also 90 degree. Okay. So that means our formula is correct. Again the same thing. Now again you can check if both of these vectors are in the same direction, a bar and b bar, then we have seen already that magnitude of a bar plus b bar is going to be addition of these two magnitudes. So see, now this theta is 0, so if I put theta is 0 here, the resultant will be square root of a square plus 2ab. What is cos 0? Cos 0 is 1, so 2ab plus b square. Now this is a plus b whole square, the square root, and then you have a plus b. It is simple number addition, a and b, right? Both of them are in same direction, you just add numbers, right? This is going to be your resultant in this case. In cos of 180 degree, that means both of them are 180 degree opposite of each other. This is a bar and this is b bar. If both of them are 180 degree opposite of each other, you will get cos of 180 as minus, and you will get it as a minus b. This is the magnitude. Okay, so this is how it works, right? Let me see if it is visible or not. Yes, it's visible. Okay, now the next thing that we will do is we'll find out the direction of the resultant vector. Let's look at that. I will erase this one. Yes, let's look at the direction. So what is the direction? You know that the direction of the resultant vector can be specified if I specify this angle alone. Let's say this is angle alpha, the angle that it makes with the positive axis. So from here I can see tan alpha is equal to RS, that is opposite side, upon adjacent side, which is PS, right? RS upon PS. Now RS upon PS can be written as PQ plus QS. PQ plus QS is equal to RS. RS is SR, which is B sin theta, upon PQ plus QS. PQ plus QS is A plus B cos theta. A plus B cos theta. So this gives you the direction of the resultant vector. So alpha is tan inverse of B sin theta upon A plus B cos theta. So this is your direction of the resultant vector. So parallelogram law of vector addition is very crucial because it tells you not only the magnitude of the resultant vector, but as well as the direction of that vector, which is nothing but the angle that the resultant vectors makes with the positive x-axis. In next video, we will solve questions on parallelogram law of vector addition. Right? Thank you.